Hello, this is Scott. Welcome back to my YouTube channel, where I cover a variety of different data science and analytics topics, as well as go through tutorials in open source software as well as commercial software. Today we're talking about R, and we're continuing on with time series. In fact, this is part 2 of seasonal ARIMA models. And let's go right into RStudio. I don't have really any other slides here. So then last time we used this FPP2 package by Hyman and the forecast. And we also looked at the plot of this European quarterly retail trade data up till 2011. I think it's 96 to 2011. And we had already plotted a couple of plots. So we had differenced this data. First difference with the lag of 4, and we looked at the series, and we see that we've got some AR going on here, spike at, and even the PACAF, we've got a spike at 1, 2, and 5. So we said, well, let's go ahead and do a second difference of 1 on that data, since we know that that's going to be required. And then this is kind of what we got and kind of where we left it. So picking up with that, we see here in the autocorrelation ACF, we got a spike at lag 1, and that kind of suggests an MA of 1. And then the significant spike here in the PACAF really kind of suggests an MA1 component as well. So a seasonal MA component in this PACAF. So let's try an ARIMA 011011. Right. So this is new code where we're starting, and we're essentially using seasonal ARIMA here. Again, remember, this is capital A. This is from Hyman, this function here. So with that, we've got a spike at 2 in the ACF and also in the PACAF as well. So let's try this an ARIMA 012 and 011, and then check the residuals. Check the residuals there. And this is what I get here. I'm also kind of curious. Let's see what the, let's do the same for, so got a spike here at 3, and let's look at for a 1311, and we're going to get the Kaiki information criterion here in just a second. That actually looks better. So let's look at the overall fit statistics. And so for the first one, again, this 01211, sorry. We get, here's our coefficients, theta 1, theta 2, and then the seasonal data. And then the Kaiki information criterion is 73.33. The adjusted, the corrected Kaiki is 74.27. So what would that Kaiki corrected be for this 1311? And I see here are my parameters, my thetas, and then I can see that it's 68, the corrected the raw is 67.26. So this is better. The other thing that we've been talking about is the auto ARIMA process. So we'll do that in just a second, but let's go ahead and forecast this out and see what it looks like. This is very interesting, right? So, and pretty telling. So here's our forecast, and our limits are 80 and 95% confidence or prediction bounds for this series itself. And then if I use the auto ARIMA, just straight on it, right, with all the defaults, I get a 69.24 and 70. All right, so this is going to be a stepwise, and then if I created stepwise false, in other words, I'm a little more compute time, but I'm going to open up the search capability, and it didn't take much longer, and it ran right here. And so the recommendation there from the auto ARIMA is an ARIMA 013011 with M4. Again, this quarterly seasonal data. So kind of interesting, and we'll quit there. We'll pick this up with the last part 3, where we cover a different example. Hope you can join me then.